So in this video we are going to do a very interesting experiment, okay, including various salts. So what are the salts we have? First of all, we have the common salt, that is sodium chloride, NaCl, okay. Then we have potassium nitrate, that is KNO3. Then we have aluminium chloride, that is AlCl3. And finally zinc sulfate, ZnSO4. So these are the 4 salts, but we have 4 more, okay. So let's try to see. Next we have copper sulfate, that is CuSO4. Then we have sodium acetate, that is CH3COONa. Then we have sodium carbonate, that is Na2CO3. And finally, now absolute final one is sodium hydrogen carbonate, Na8CO3. This is also known as sodium bicarbonate. So these are the 8 salts we have. We will be performing a certain experiment with these salts and then come to various conclusions. Now let's try to see it. Okay, so what are we supposed to do? First of all, take small amount, approximately 0.5 gram of each salt in separate test tubes. So all of these salts we talked about, you will be taking all of them in each test tube. Here you can see one test tube, but there will be plenty more, okay. So 7 more obviously, and you will be taking 0.5 gram of these salts in those test tubes. That is the first thing. Now add about 5 ml of distilled water to each test tube. So first of all, after you add 0.5 gram of each salt, you will be adding around 5 ml of water to each test tube, okay. And then gently shake or stir each test tube to dissolve the salt. So here in this experiment, our main motive is to dissolve the salt in the test tube, like in the water, not in the test tube. You have to dissolve the salt in the water which is there in the test tube. For that you can either shake it or stir it, whatever you want to do, but then you have to dissolve it. That is the thing we need to do, okay. Now, so you do it, you get something. We will be now trying to judge whether they are acidic or neutral or basic. So before that, we will be also doing a litmus test and find the pH. You know about pH. So lower the pH, it will be acidic, higher it will be basic. And we have pH papers through which you can actually, it's 0, it's ranging to 7 and then 14, of course still 14. So you can find the definite pH of all these salts, like all the after mixing the salt with water, whatever element you are actually getting, you can find the pH of them, okay. Okay, so now we will be having a chart and try to analyze the result, okay, and also why is it neutral or acidic or basic or whatever it is, okay. So firstly we have sodium chloride, that is NaCl. Solubility in water is soluble. Litmus paper test, there was no change and the pH is around 7, okay. Now we are judging that because the pH is around 7, okay, close to 7, it's neutral. Of course we know that pH when it's equal to 7 or around almost equal to 7, it's neutral. But try to observe something. Here the parent acid is hydrochloric acid and the parent base is NaOH, that is sodium hydroxide. Now why is it neutral? It is neutral because both the acids we have in this case are strong, okay. HCl is a strong acid, NaOH is a strong base. Both of them, when they are coming together, they are giving us a neutral component, okay. The salt, the mixture will be actually neutral, okay. This is the first thing. Let's go to the next one. So next salt we have is potassium nitrate, which is KNO3. It is also soluble, litmus paper no change. This pH is also almost equal to 7 and it's neutral. HNO3, it has the parent acid, that is nitric acid, which is again a strong acid, okay. It's a strong acid and the parent base is KOH, that is potassium hydroxide, which is also a strong base. Strong acid and strong base, as I told before, it will be giving a neutral result, okay. The pH will be equal to 7, almost equal to 7, and the result will be neutral, okay. Okay, so now we have a question. What is the parent acid of potassium nitrate? Okay, so option A we have sulfuric acid, option B we have nitric acid, option C we have hydrochloric acid. The correct answer is option B, nitric acid. We discussed how a strong acid will give it a neutral component. At the end it will be neutral. So Nitric acid, we already studied in the previous chart, will be the parent acid of potassium nitrate. Okay. We are now coming back to the chart. Aluminium chloride is our next salt, so AlCl3. It is also soluble, and in this case the blue litmus will turn red. Red means what? Red means, first of all, the pH will be less than 7 and it will be an acidic component. Okay. Now acidic component, now try to see the parent acid, HCl, hydrochloric acid, and the parent base is AlOH3, that is aluminium hydroxide. Try to understand why are these things happening. I'm telling that blue litmus is turning red, the pH is less than 7 and it's an acidic, the test is giving us acidic result. Why is it actually happening? Because hydrochloric acid, like the previous acid, nitric acid, initially also we had hydrochloric acid. So just like nitric acid, hydrochloric acid is a strong acid, but aluminium hydroxide is not a strong base, it is a weak base. So basically a strong acid plus a weak base, when they collaborate, they are giving us an acidic component. So which is why it's turning red, the litmus pH is less than 7 and it's an acidic component. Okay. So similarly we have zinc sulfate, ZnSO4, which is again soluble, no change or slightly red. Okay, the litmus will be slightly red, which is where the pH is also less than 7. We don't get the accurate pH, but it's less than 7 and it's slightly acidic, which means what? From this one you can understand that sulfuric acid is a strong acid and zinc hydroxide is a weak base, but again the difference in the strength and the weakness of the acid and base is not as much as it was in the previous case, hydrochloric acid and aluminium hydroxide, which is why it was entirely acidic. In this case it's slightly acidic. Okay. Now going to the next salt, we have copper sulfate. Okay, that is CuSO4, copper sulfate. It's also soluble in water, and in this case blue litmus is again turning red, the pH is less than 7, it's acidic, parent acid is sulfuric acid, strong acid, and copper hydroxide is a weak base, which is why it's acidic, less than 7, and litmus is turning red. It's as simple as that. Now we have something different. We have sodium acetate, that is CH3COONA. It's again soluble, but in this case the red litmus is turning blue, which means the pH is more than 7, and pH more than 7, litmus is turning blue, which means it will be basic. It's basic. So now when you understand it's basic, simply try to understand. I told many things, weak acid, strong base, strong acid, weak base. So in this case, if the component is becoming basic, what it has to be? The base has to be stronger, NaOH, sodium hydroxide, it's a strong base, but the acid has to be weaker, that is CH3COOH. Acidic acid is weaker. When you compare it to the previous acids, sulfuric acid, hydrochloric acid or nitric acid, acetic acid is weaker and sodium hydroxide is a stronger base, which means the final result will be basic. Okay. Then we have sodium carbonate, which again will be following a similar path, Na2CO3, it's soluble. Red litmus is again turning blue, the pH is more than 7 and it's basic, because again carbonic acid is a weak acid and sodium hydroxide, again in this case also sodium hydroxide, so it's a strong base. And finally we have sodium bicarbonate, that is NaHCO3, which is soluble. In this case also red litmus is turning blue and the pH is more than 7, which is why it's basic, the result is basic. And carbonic acid, as we already discussed, carbonic acid, it's a weak acid, and NaOH, as we discussed, it's a strong base, which is why the final result is basic. So you saw how the final result, acidic, basic or neutral, is varying depending on the parent acid or parent base. So it's very important to understand. So in this video we particularly focused on an experiment, right? The experiment was, we took different salts from, like, ranging from, here you had sodium chloride, potassium nitrate, aluminum chloride, zinc sulfate. So these were the initial salts, and then we had copper sulfate, sodium acetate, then sodium carbonate and sodium bicarbonate. So we had different salts, and we tried to test that after mixing in water whether they are soluble. All the salts are soluble, of course, but how are they? What is their nature? So is it acidic, basic or neutral? And we found that the salts in which the acids were stronger, the parent acids were stronger, they give us acidic nature. And in which both the acid and base are equally strong, in that case they are neutral in nature. And finally we also found a few salts where the bases are stronger, so they give us basic nature. So these are the takeaways from this video.